Thank you, Mark. Thank you. And thank you for having me. It's really great to be here. I'm Sara Yeo. I'm faculty member, professor in the Department of Communication at the U. I'm also associate chair. Mark, I'm associate chair now. Poor thing. Yeah, it's great to be here. Um, I also direct the STEM Ambassador program, which I will talk about briefly on the last slide. And so often when I start these talks, I talk about how I came to science communication. I'm trained as a scientist. I grew up in Malaysia. I moved to Honolulu to get an undergraduate degree in oceanography. I have a minor in chemistry. I know there was an OChem class in here earlier. I'm a PChem person, right? There are OChem people and there are PChem people. I'm a PChem person. I thought I was going to study carbon cycling in the world's oceans when I was an undergraduate student at Hawaii Pacific University. I got a master's degree at the University of Hawaii in oceanography. Turns out I was a microbial ecologist, sampled and filtered copious amounts of water after disturbances, storms. So it was not a pleasant fieldwork experience. So from there, I got into an environmental engineering program at the University of Wisconsin-Madison. Madison has a lot of aquatic systems and northern lakes, and so we were studying very similar things, looking at microbial ecology, community dynamics in surface waters of lakes and bogs primarily. But while I was there, I would do as many of us as grad students do, a lot of outreach activities, perhaps, right, where you're talking to non-science audiences. I mean, they have a science affinity. They live in a town with a university where knowledge is being produced. They're coming to a science fair. And I would talk with them about microbes, and somehow it always got around to recycling, right? And so I couldn't really, I don't know, it was about climate change, right? And their part of it was like, I recycle. Great, but I'm trying to tell you about these tiny microbes that I'm super interested in. It turns out more people aren't as interested in microbes as I was. And so I took a course in engineering professional development that was around creating a science engagement activity. It was with Sharon Dunwoody, who was in the journalism school at the University of Wisconsin. She's sort of one of the first science journalism scholars. And from there, I sort of found my way to the College of Ag and Life Sciences, where they had a science communication program. A lot of land-grant universities have this program that has turned into communication. It often starts out as agricultural communication. So University of Missouri has something like this, for example. And I got a master's degree studying hostile media perception and climate change. And I liked it so much, I found my calling as a social scientist, ended up getting my PhD there. My PhD was about how we seek and process information based on somewhat on our priors, right? So primarily our value predispositions, specifically political ideology. So Hawaii was nice, Wisconsin was great, and then I came here, and so this path to communication, which admittedly is a very circuitous path to this scholarship, really informs what I study. I think about how we can communicate science in a strategic manner. Primarily, I think about how mediated messages, so any messages about science that we get from media, right, can be designed and what are their effects on audiences. I think about how we select information, right? A lot of social psychology work goes into this, Festinger's theory of cognitive dissonance, how we might select or avoid information that doesn't fit with our priors or our predispositions. And then with all of that, I think about how we process that information. So heuristics is just a fancy jargony word for mental shortcuts that we use. Some of these shortcuts are things like political ideology, religiosity, right? Our identities. And then I also think about how emotion affects our processing of information, right? We often process information through emotion. And all of this work is done through the lens of science, environmental topics, risk topics like energy, new energy technologies. And then I have sort of my focus areas when I think about strategic tactics in communicating about science. Most of my work is on humor, but I've recently started to look at curiosity and situations where media messages might elicit some curiosity. So as the curiosity work is relatively new, I'll be talking primarily about the humor work. But first, let's set the stage here, thinking about why science communication is important. I think this audience probably has some inkling about that, but let's articulate that, right? So here are some data from the Pew Research Center. You can go online, get these data. They do public opinion polls about people's attitudes towards science, their media use when it comes to science, not just science, they do it about a lot of other topics as well. But in a 2023 poll, they found that fewer Americans say that science has a mostly positive effect on society, right? And this has been a declining trend since 2019 when something clearly happened. Okay, right? So fewer Americans say science has had a mostly positive effect on society. We see that confidence in scientists is up slightly since the pandemic-ish, right? But it has declined since then. We also see that scientists are widely seen as intelligent individuals, but very few are thought of as good communicators, right? And this, when I talk about trustworthiness and the idea of trustworthiness as a communicator, there's different dimensions of trustworthiness, expertise being one of them. Scientists tend to score very highly on expertise. People view scientists as experts. What we don't score very high on are things like warmth and benevolence, right? The idea that in order for me to be a trustworthy messenger, you have to trust that I have your best interests in mind. You have to like me as a person. Right? I might have to portray a warm persona and so on. Right. So continuing, if we split that up even more, we see that different groups in society have very different views on scientists' traits, right? Here they point out honesty in particular. So the red dots are those who are Republican or leaning Republican in the sample, the blue Democrats leaning Democrat. And you can see the various scientist traits that they were asked about, right? And you can see where people fall on that. Socially awkward is, whoa, one of my favorites. And cold, right? So when we think about ideas of benevolence and trustworthy messengers, cold and warmth, things like that, right? All these kind of traits that make us personable, right? And humanize us are things that scientists often don't think about when we think about trustworthiness. We think about expertise and credibility, not so much about warmth, likability, benevolence. Okay, so what we see from these data, perhaps, is an eroding. Oh, it's not me. I thought it was me. Somebody's just turning the lights on and off. I really thought I was doing it, but it's not me. I thought it was me. So what we see here, right, are just data that there might be a little bit of erosion of public confidence in science and scientists, right? So that's one aspect of it. The other aspect is that most of us don't learn about science in the classroom, okay? So here is a figure from a now quite dated paper by John Falk and Lynn Durking. They're science education researchers. This represents the lifespan of an average American. We have, lifespan in years on the X, the time of day on the Y, and then going back the months of the year. And you can see in the pink and green boxes how much time, right, in our average lifespan do we spend in formal education. And then the amount of science education that someone gets in there is quite just a few drops, really, okay? Not that many undergraduate students will take many science courses. You have to opt in to sciences, right? And the point is, this is why we have liberal arts education, so you get some exposure to all these topics, but not that many of us choose to go into science. It's actually quite the minority. So the rest of the space, all this blank space, is really open to wherever we may or may not get science, right? We could, if we are fortunate enough to live in a city with a university, with a museum, we might choose to expose ourselves to science information in those kinds of informal ways, but many people do not live in cities where there are institutions of higher education, where there are museums, right? Where there are places that one might be exposed to science. And so a lot of this space is also filled by media, right? Where we get information about science if we choose to attend to that. And when it comes to media, we had 3 channels. Some of us will remember this. Every time I say this talk or give this talk and show this slide, I'm like, the proportion of us who remember this is decreasing. But in the broadcast era, we had 3 primary channels. We had shared media experiences because perhaps the television was on while we were waiting for the entertainment program that came on after the news. So we might have had some inadvertent exposure to news information, even if we weren't necessarily paying attention. I was just talking to Ryan, we could go to work the next day and have a conversation about the topics that we may have seen on the news the night before, right? And we all sort of had a sense of the topics that we were talking about. Okay. Media look far more fragmented now. These are just sample, right? Just a small sample of the kinds of outlets that one might attend to. And in fact, I didn't put primarily entertainment channels on here, but if you so choose, you could entirely ignore public affairs information, right? For the Kardashians, okay? And so now we get to pick and choose. We have much more of this me culture curation online, right? We get most of our information online, if not through these platforms, through social media, some of which are represented here. And science in an online environment looks very different from science in the broadcast era. What we have now are things that contextualize information for us. So even if we never click on the article link and read the full article, we are able to mentally shelve this information, perhaps new information, just based on who has posted it, who has liked it, who has commented on it. So I often give the example of a Facebook friend that you haven't seen in maybe 10 or 15 years that you were friends with, perhaps in high school or middle school. And from their Facebook posts, you can tell that their views have diverged from yours. Right? I think we all have those friends on Facebook. And then they post something about science. You have already formed some opinion, right? And have mentally shelved that information just based on who has posted that, not based necessarily on reading that particular article that they posted. Just by virtue of who has posted that, who has liked it, who has commented on it, you form some opinion of that, and it's enabled you to sort of mentally shelf that, right? And so often so I have a couple of colleagues, we go to a lot of science conferences, so not communication conferences, we go to ESA, we go to AGU, and we talk to scientists about their communication efforts and their objectives for communication. Quite often scientists say this, right? I want to share information, facts, so that you can form an opinion, so that you can make an educated opinion. Well, what we know from decades of political science research and political communication research is that, in fact, when people are more sophisticated, so perhaps when they're more educated, simply giving people information is a way, they use it to rationalize to fit their own predispositions. So any views that they might have held, they take that new information, right? And it's rationalized to fit their views. As humans, we like to think we are rational processors of information. In actuality, we are good rationalizers of information, okay? But of course, this doesn't mean that information and facts are not useful. The thing is, we have to be specific about what kinds of facts we're sharing. Facts run on a continuum from textbook facts, right? About, I don't know, benzene rings having 6 carbons to risk and benefit information related to science that might be useful to our daily lives. And so we talk about this as the knowledge deficit model, the idea that giving people information isn't going to change their minds, right? So that they align their opinions with that of experts. But I think we've spent a long time in science communication vilifying the knowledge deficit model and vilifying information without much specificity. We should be more clear because information is important, but the type of information matters, right? Factual information about CRISPR is not going to encourage someone to get vaccinated. Risk and benefit information might, right? About the benefits, risks of getting vaccinated, okay? Different kinds of information. So often I hear, well, again, I want to give them more information. If scientists are a little bit more sophisticated in their science communication journey, what I then hear is this: we need to tell more stories, right? We need to tell more stories about our science. And yes, that is true. But I would argue that telling more stories is not always strategic if you haven't thought about to what end. To what end do I need to tell these stories? What is the objective that I have for telling this story? Am I encouraging new generations of scientists, new generations of students to be excited about science? Am I trying to convince them to get vaccinated? Am I trying to think about climate mitigation and adaptation? Am I trying to encourage them to make decisions about that, right? I would ask to what end, and I do think that there's a lot of communication where we don't really necessarily think about to what end. And so learning, one of my collaborators is in public relations. He does science communication, but he puts a public relations sort of bent on it. In public relations, it's always about to what end, right? What's the goal? And so I think about this when it comes to, right, when we think about doing science versus sharing our science. And no scientist I know likes the word marketing, right? But if we use the analogy of a company that is developing a product, they put as much money into developing the product as they do in marketing the product. I feel sometimes in science that we've put a lot, decreasing amounts, but a lot of money into doing the science. But we haven't really invested in sharing our science and encouraging, right, people to understand why the science is important. Okay, so I also talk often, scientists like to think about trust, right? Trust in science. Trust is a very complex concept. Intuitively, we feel like we know what trust is, but when it comes to really thinking about what are the aspects of trust that are important, when scientists think about trust, I think what most of us are thinking about is that we want people to have some kind of behavioral trust in us, right? We want people to allow themselves to feel vulnerable to the research that we do informing their decisions, okay? And so often there are different dimensions of trust that are relevant to behavioral or pseudo-behavioral trust. This idea of ability or expertise, again, scientists score very high on expertise, right? Everybody, for the most part, people trust scientists. This changes a little depending on whether you call yourself a climate scientist or not. I think climate scientists tend to be slightly less trustworthy for various reasons, right? Or perceived as less trustworthy. It's not that they aren't trustworthy, Matthew. They are perceived as less trustworthy. So there's that. There's also benevolence, the idea that, right, I'm doing this in your best interest. I want what's best for you. Openness, transparency, and integrity. And so we know from decades of research in marketing, advertising, and public relations that trusted messengers are those who are liked generally, right? Not only do you have to seem like an expert, you also just have to seem like not a jerk. Okay. So in recent years, in the past 10 years, I would say a lot of organizations have become very interested in science communication. So we just had the call for awards in excellence in science communications from the National Academies. If anyone saw that, somebody should hopefully have submitted to that. NASA is very interested in communication. Partly, I think it started way back when, but I was sort of introduced to the NASA world of communications during the arsenic life controversy in 2011. That was really a communication faux pas for NASA, and it had a lot of fallout. And so they're very interested in that. NASA is really interesting in this way because most of the astrobiology communication is related to preparedness for communicating about the potential discovery of life in the universe, right? And so they're sort of forward-looking in that way. So all this to finally get to my research primarily uses a framework of strategic science communication. So this is a framework that some colleagues came up with. It's based on social psychological theories, theory of reasoned action, theory of planned behavior. And what this is, right, things that we usually think about: goal setting, objective setting, tactics, objective evaluation, goal evaluation. I'm going to ignore the evaluation parts of this for now. Most of my work focuses on the front end of this. And in this, goals are defined very specifically. Goals are defined as long-term goals that are behavioral goals. So when we go out and ask scientists, to what end? What is the behavioral goal associated with this piece of communication. It is often quite hard, right, to articulate what is the behavioral goal. We can often have short-term objectives that are about changing people's beliefs and perceptions or feelings about science, but longer-term goals are much harder to articulate. My research is primarily looking at tactics. Science communication as a field is relatively young. Communication is a relatively young field, right? Science communication, younger. And so we don't have a lot of empirical evidence about tactics that work in the context of science. Because we can agree that it's not the same as advertising something, because their outcomes are always intention to buy something, right? And there's not always sort of an end user product when it comes to science. And so I think about specific tactics, and mostly I've been thinking about humor. How can we use humor to humanize scientists as messengers? How does it affect your trustworthiness or credibility? How does it affect people's intentions to engage with more science content downstream? And so on. And then different types of humor. Humor comes in many different forms, right? I picked humor because it's also something that's very ubiquitous, right? It is every day, I hope you laugh at something. I hope. But it is also quite complex, right? The types of humor that we use. And so in this research, my work often takes this form, right? I vary a message. Usually it's a social media message. I primarily study social media because that's where a lot of people are getting information and news about science from. So I vary a message some way. I measure some outcome psychological state that they might have. In the context of humor, I measure how funny it is, right? How funny they think it is, how much mirth, how, you know. And it may not be laugh out loud funny, because let's be real, they're science jokes. So, you know. And then some persuasive outcome at the end, right? And because everything, I think too about what kinds of individual traits might moderate the particular message, right? When I say this, I think about like if you, we all are going to process information in different ways, right? And based on who we are as individuals, based on our values, based on our predispositions. And these are the kinds of individual traits I think about. Okay, so the first thing we wanted to do in sort of this long project on humor was think about how much humor there is on social media, right? When I started this work, it was in 2017. Twitter was still Twitter. And overly honest methods, the hashtag and hashtag fieldwork fail, were two hashtags that scientists were using to share, kind of poke fun at the process of doing research, right? One might say poke fun at the scientific enterprise. Okay. This is just an artist rendition of some of the tweets that came out, which I really enjoyed. And so what we did is we sampled posts about science that had the hashtag science and the hashtag funny or joke or humor. There's a whole list of keywords. We don't need to go through those. And we tried to quantify how much humor and what kinds of humor is found on scientific topics on social media. And what we find is that, so the blue bars represent Twitter, the red bar is Instagram, is that a lot of humor is sarcasm and satire. It's the funniest kind of humor, right? This is why stand-up comedians often use satire, sarcasm, because it's the funniest kind. And then the next sort of most prevalent kind is wordplay. I think of these as dad jokes, right? Which are great, but they're not as funny as satire, okay? So great, we have a sense of what the most common types of humor are. And what we see, or what we did see then, was that humor was quite often recommended to scientists engaging with media, right? But there's sort of no empirical evidence of what is the effect of doing that, right? So this is like saying, go out and do the thing, good luck. Okay. So our first question really was about how is humor associated with people's engagement with science? If they see something funny about science, does it then encourage them to engage with more content, right? Does it encourage them to share it or like it, and so on? And because I believe in replication, I did this experiment twice with two different with different topics, but similar designs. And that particular design is, I'll show you the humor manipulation in a minute, but our outcome variable is intentions to engage. The psychological thing that we measured is experienced mirth. And then the individual trait that I looked at is need for humor. So need for humor is like a personality trait. It's not one of the big 5 personality traits, but it is a trait that we all have. We all lie on this continuum of a need for humor, where some of us want to be the source of humor more, want to be around funny people more, right? And it's just a continuous scale of that. Okay. So I'll show you the experiments. So this is the no humor condition. We had 4 conditions, no humor, and then we used satire and wordplay because we used anthropomorphism and wordplay. And so this is the no humor condition. And this is an actual, I modified the joke to fit the no humor condition. You can see we use the hashtag science, we use the hashtag fact. All the social media metrics were kept consistent, right? 288 retweets, 480 likes. And then the response to the original post amplifies that particular condition, okay? So no humor. And then this is the sort of other end of the spectrum where there's anthropomorphism and wordplay. So anthropomorphism, where the atoms, right, have little faces, the electron is running away, it has tiny little feet, if you can see that. And then there's wordplay in it, right? Very common dad joke, I think I've lost an electron, are you sure? Yeah, I'm positive. And again, you got to keep an eye on it. Haha. Yeah, that's about how many chuckles I get when I talk about this study. And then we have the 2 in-between conditions where we remove one type of humor. So this one only has anthropomorphism. There's no more pun. There's no more wordplay, right? And then no anthropomorphism. Okay, so we anticipated that, right, the combined condition people would find that the funniest. We compared randomly assigned to one of the 4 groups, compared between the groups, no humor condition, least funny, and so on. And that is indeed what you find when you look at the no humor condition compared to the anthropomorphism wordplay condition. So respondents in the combined condition experience the most humor. There's no difference in sort of the 2 middle conditions. And then when we look at how does need for humor affect the outcome variable, what we see is that those with higher need for humor, right, also thought it was funnier. That is natural, but then also reported higher intentions to engage with the content, share the content, talk about it, like it, and so on, retweet it. Okay. So this is done for something that you might encounter, but the topic itself is very basic science, not particularly exciting or interesting. And so we wanted to replicate this with 3 other topics. We did topic of global warming, artificial intelligence, pre-chat GPT. I should now have to preface this by saying pre-AI being like a thing that everyone knew, and microbiomes. And so same setup, very similar experiment, but and I'm just showing you the 3 end conditions here, right? So this is the full humor condition. And we varied the type of humor that was in it. So there's satire and wordplay in the climate change one, right? There's anthropomorphism and satire in the AI one. So here it's self-driving cars. And then in the microbiomes, anthropomorphism and wordplay. Okay, so this is the end conditions. In each, there were 4 conditions, about 500 people per condition. We compared them. And what we see is that, so here you're looking at the levels of mirth by condition for each of the issues. So you have global warming, AI in the middle, and microbiomes. And you can see that for AI and microbiomes, the same pattern, right? No difference between the 2 middle ones, no humor, lowest, combined humor, highest. But then in global warming, it's just sort of kind of funny. No difference between groups, okay? And that, we think, partly is because there's anthropomorphism in all of them. All of the dinosaurs were like talking, right? They're all anthropomorphized. But also, it's an issue that has been on the public's agenda for far longer than any of these other ones, right? AI was certainly like a middle kind of increasing in attention issue. Nobody knows about microbiomes, except for a very small community thinking about fecal microbiome transplants, right? So again, respondents in the combined condition reported the highest levels of mirth, and similarly, the same between the two middle conditions, right? And we were able to replicate the findings for AI and microbiomes when it came to need for humor. The higher you score on need for humor, right, the more likely, the funnier you found it, the funnier you found that, the more likely you were to say, I'm going to engage with more science content. Okay. So what? What we found, at least in this set of studies, is that making people laugh is positive for science communication. We have other studies that show very similar things, right? Humor is positively associated with people's engagement intentions. They're much more likely to share science, talk about science, right? Retweet, all these kinds of things if they found it funny. Humor, in some of our other work, we looked at the scientist as well, who was using the humor. It makes you more likable, is what we found, without undermining your expertise. But the type of humor matters. So the next thing we did was we looked at satire and how satire might affect an audience's perceived trustworthiness of the scientists, right? So we had a satire condition that was pretty gentle, and then we had a much harsher satirical condition. And in satire, there's always some level of aggressiveness, right? That is the definition of sarcasm and satire. You are attacking someone. There is always a target. And so we measured perceived aggressiveness in addition to the amount of mirth that respondents got. So again, people were randomly assigned to either the gentle or the harsh satire condition. We compared them across. And what we see is that mirth is positively associated with perceived trustworthiness. So the funnier they thought you were, the more trustworthy they also thought you were. However, aggression and that perceived aggressiveness is negatively associated, right, with trustworthiness. And so what we learned here is that basically you are sacrificing, and so I'll just show you the mean levels of trustworthiness, aggressiveness, and mirth in the various conditions. So the funniest conditions are the two satire conditions, right? That makes sense. But the thing is, you sacrifice some funniness, right, when you take out the aggression. And so what we learned from this is that satire probably isn't great when it comes to communicating science. And it sort of echoes some of the research in political communication on late night shows like the Colbert Report, right, Late Night with Jon Stewart, where some of the research on those late night satire shows has found that that kind of humor can really undermine people's trust in political actors and political institutions. And so here we get to think about, well, the mechanisms of that are probably because they are also perceiving aggression, right, in addition to mirth. Okay, so I think that's mostly what I wanted to share about my humor work. There are some other things that I do. I've been collaborating with some chemical engineers on air quality research. We did some interviews with high school athletic trainers thinking about how they use air quality information for decision making on the field. And we implemented like in situ monitors for that. So that was fun. I also think about climate anxiety among students. And this in particular had to do with the curriculum that they were learning in the School of Environment and Sustainability Studies down at the U, where they learn about climate change early, but they don't really learn about solutions early, right? And it causes a lot of, at least the instructors thought it caused a lot of anxiety among their students. And so we were studying that. I also have more work on comedy and humor, because one of the things that I would like to think about and kind of parse is whether the humor works because it's related to science, or whether the humor works because it puts you in a better mood, right? Maybe you can just watch something funny unrelated to science and it puts you in a better mood, and then you're just more likely to share something, right? So there's competing hypotheses there. I've also started doing some work on curiosity. I think my hypothesis is that sort of repeated exposures to instances and messages that make you curious might encourage long-term curiosity, right? We think about like science curiosity, for example. Can like repeated exposure to content that makes you curious, that elicits curiosity, make you a more science curious person? I do some work on risk communication and biomanufacturing, risk and benefit perceptions around creating stuff, right? Using microbes. And down at the U, we have a Utah Forge project. So there's some risk communication work around geothermal energy as well. But with that, I will tell you a little bit about the Science STEM Ambassador Program. So I direct this program. This program was started by Nalini Nadkarni, who is in biology. She's Professor Emerita in biology. And the idea here is really around encouraging scientists to take off their scientist hat and put on their everyday other hats, find communities with which they're already sort of integrated or have some affinity with, and use those ways to share research, right? Use those relationships that they can build there to share research. And so I'm happy to talk more about this if you have questions, but really working around trustworthiness, beliefs around like benevolence, not so much credibility because you're a scientist, right? Coming into a community and asking them what kinds of science questions would you like answered? I can design an engagement event around that, but thinking about openness and benevolence and things like warmth. Well, thank you so much for having me. I'm happy to take any questions, and I'm really looking forward to the panel.
What's the funniest science joke?
Wow. I'm pretty low on need for humor. I'm a low need for humor scorer. I don't know. I did go to, was it AAAS? Geoscientists have a lot of really good stickers of puns, like geology rocks. That's their favorite. Yeah, geology rocks. But puns are actually really good in the context of science because they're very benign, right? They don't have a target really.
Are your STEM ambassadors faculty, students?
Oh yeah, they're mixed, yeah. Primarily graduate students, but we often have some postdocs, and we will run a faculty cohort every other year, I think. Yes, so it's a cohort program. They're in there for a semester. They're not meeting every week, but they have maybe 5 or 6 meetings over the semester. And then they meet and connect with their community partners to think about like, what kinds of science questions do you have? How can I design an engagement activity around that? Yeah.
So, what are examples of some of the community partners? Are they schools or?
They can be schools. We try to encourage our ambassadors to engage with people who maybe don't have as much access to science, right? So Nalini's Prisons project came out of this. We would engage with, right, incarcerated individuals. We do grocery stores. We had scientists, she was a microbiologist, make kombucha, teach others how to make kombucha, right? Yeah, we had like a crochet chemistry thing. So it's really, the program manager is connected to a lot of communities. And so we try to match up scientists with those communities. Wasatch Community Gardens is another one that we've done. So, yeah.
All right, so my question is going to be about some of your slides. Yeah, so I did a class presentation on Tuesday, and one thing I did was to project the screenshots of some papers, which you also did. But I had only 5 minutes for that presentation. So I was very fast in my presentation, and the feedback I got from my classmates was, instead of having screenshots of those papers, I should replace them with maybe bullet points. Yeah, but something we did differently was that we spent enough time when you had a slide that had screenshot of papers. Yeah, so my question is, going forward, if I have enough time, should I still project slides that have screenshot of papers, or should I replace that with bullet points? Yeah, so I had my master's in China, and something common with Asian professors. Yeah, so they always project. Yeah, so it's something I copied from them, but the feedback I got from my classmates is making me having to rethink on what to do.
I prefer less words. generally on my slides. That's just, I'm just like a less words person. Because if you're reading the words on the slide, you can't listen to me talk. Our brains just don't process that way. And so I would always opt for less words, whatever route that takes you, generally.
Have you parsed out types of audiences that in opposition to science, open to science, affinity to science?
Yeah, most of my work is actually just on like a general public, so a representative public. I guess I unintentionally did that when I did some climate change communication. Climate change communication is notoriously challenging, right? Because there are very clear groups, but I haven't looked specifically at like sort of pro or anti-science audiences. Which actually would be a great question for if it's just like I feel I'm in a better mood, right? Versus like it's actually the science.
You talked a little bit about strategy at the start, strategy and the importance of setting specific goals for communication. What are the different kinds of goals that we should be considering?
Yeah, and I think so. Maybe what we should do is why would you communicate? Like in what context would you communicate and what do you intend for that communication? Generally, if like I were just to ask you a question like this out of the blue, anyone, why do you want to share your science?
To feel superior.
Okay, well, that's a behavioral goal for you. Nailed it, Matthew. But, right, so the general answer I get is so the menu of behavioral goals is not set. It's like going to a bespoke restaurant where you get to decide what you would like, right? But thinking about to what end is a question that I think I've found very useful for scientists and really pushing to what end, right? Because I think scientists are hesitant to say, I would like people to make decisions that align with the science, even though that might actually be what they mean. It feels icky as a scientist.
Well, and another one that would probably go in the same basket is I want the public to continue to support my research.
Right. Yes. I want the public to continue to fund science, right? But in order to, but that is actually a behavioral goal of to what end? You just have to be able to articulate that and be honest about that goal. I think quite often we're not honest about what the behavioral goals are, which then muddies up the rest of the communication process, right? Because if I can't be honest about what my behavioral goal is, I can't figure out what the actual objective is. And I may be unconsciously, I'm not saying I'm being dishonest on purpose, it just doesn't feel comfortable, right?
How do I change that behavior among scientists? Because I find scientists to be incredibly frustrated when those goals are not met, right? When their research does not get funded, when people don't take action in alignment with this, they get frustrated. But on the front end, they won't admit that that's what they want. So how do we change those behaviors?
Yeah, good question. One of my colleagues is just very persistent when he works. So he works with LTRs and he's just very persistent about like, to what end, to what end. And I think it does take quite a bit of prodding along, right? But that's actually, I mean, the other things that we can change now are not necessarily about scientists, right? It's about the infrastructure around scientists for communication. Again, spent a lot of money on the product, didn't spend any money on marketing the product. And so the infrastructure, right, that helps scientists do these kinds of communication isn't there yet. Not all of us should be out communicating. I study communication and sorry, Ryan, I shouldn't be on public, you know what I mean? I'm not the person to go out and like communicate my science. That's just not me. Oh, so sorry. Not me generally. And not everybody has to do that, right? But we have to have infrastructure to help those who wish to do that. And perhaps also professionals and practitioners in this space, right? A lot of whom are freelance, right? Freelance science communicators. But imagine the good that they could do if they put that knowledge to use at an institution that produces knowledge. But that infrastructure doesn't quite exist yet. And part of it is because we don't have pathways of professionalization for science communicators. right? Every science communicator that I know now and I've spoken to has this kind of a route to whatever they got to now, right? To being in science communication, which is a lot of time spent volunteering their time, writing things that they didn't get paid for, just spending a lot of time outside of their graduate programs or whatever they were doing to gain the skills, right? And so we really have no pathway of professionalization. We have no infrastructure to support them. And so it's really hard to just poke scientists and say, well, to what end? Why are you doing this? But you don't have support to do that, right? And so, okay, the infrastructure is my soapbox because I've really been thinking about like pathways to professionalization for this because there is no clear way that science communicators become science communicators, right? Yet we agree that they're important.
Versus advocacy. So I come from a background in the private sector as a filmmaker, but one of my favorite articles to give scientists is called Stop Raising Awareness Already.
Oh,
And it's exactly focusing on what do you want people to do. You can't just say, but the public should know. What the public needs to understand is we know too much. There's too much. But then sometimes I get some pushback or some concern of then what happens when that scientist undermines their perceived objectivity, thus trustworthiness, because they're advocating. And then just another little plug, if any of you have a chance to see the documentary called The Lake about Great Salt Lake that just premiered at Sundance, it is phenomenal. And this issue is front and center of we have urgent information as scientists. We have to get it out there. But in the act of getting it out there, if we destroy our reputations and careers, like what are we doing? Do you have any thoughts on the advocacy part for practicing scientists?
yeah, I mean, I'd have to think about this a bit more, but my first instinct is to think about like transparency, right? In what you're doing and like being transparent about that. But there is something about ethics here and a line between advocacy. But I would also argue that anytime you write a proposal, you're advocating for something. So I'm not sure where I fall on this yet. I still, as a sort of researcher, we were just talking about this on the car ride up, actually. The difference between like advocacy and, you can be an advocate, but you can still do rigorous, right? Objective, I don't like using that word, but like rigorous research, right? That is transparent and, clear. There's something here that I haven't parsed out yet. It probably requires a philosopher of science, actually, to think about. Another class I didn't get as a grad student in science, actually, philosophy of science, which is interesting.
This is a little more down than me, so I apologize, but I was really taken by this idea about need for humor. Because thinking about personality traits, I mean, if you were to ask, I guess the scientific term for chillness,
Chill.
you could ask somebody, okay, where are you on a scale from chill to volatile? And you could give an answer, right? But I don't know if I could tell somebody how much humor I need.
Yeah,
How fresh is that?
yeah. So I mean, it's a validated scale, just a list of statements to which the extent to which you agree or disagree, and then you get a mean calculated from it. So it's like, I like to be the source of humor, or I like to be around funny people. I like it when people tell jokes. Some of those statements, they're not the exact statements, but something along those lines. Yeah, these like psychometric psychological measures that somebody else in psychology validated, so I didn't have to, Yeah.
So I teach a breath physical science class, and we're just like the objective, the goal is for students to understand the process of science.
Oh.
And so, how much of that do you think we should be conveying to the general public? Not just my, the mainly non-science students that are not in my field in this class. And I really do try to use like my science as an example when I'm talking about, why do we know this? But yeah, for the general public, seems to be a disconnect of what I can do in a classroom over a semester versus say, I've got 5 minutes on public radio or I'm just on Matt's show or something.
Yeah, we were just talking about this and using COVID as an example, right? The fluidity of evidence in science is not something that people are generally comfortable or familiar with. So I mean, I personally think that process is important because it helps us understand why, right? Recommendations, for example, might change because of the science, right? Because science changes and that is the nature of science. So I mean, I tend to be but it is hard to talk about the process of science, right, with a general audience, and so there's no magic wand, silver bullet idea here, right? And so I think a lot of it is like repeated exposures to small kinds of bits of science that you might get, right? And this is actually why Nalini started the STEM Ambassador program, because it's sort of like encouraging people to go outside of their science bubble, right? To talk to others about the scientific enterprise, not just about the research that they're doing that might be very esoteric, that might be very specific, but about science more broadly. It's like being a cultural ambassador for science, which is, I think, why she called it the ambassador program. It's just clicked.
Let's stop there. I think there should be some food somewhere out in the atrium.
Thank you, Zoom friends.
And then, I think we can.